Hello class, this is James Quinn again for another video. I basically ran out of time on my last video, so I'm going to pick up where I left off. And we're talking about the frequency distribution table, and we got about this far, and the next thing I wanted to show you was how to find your frequency. Well, we have our classes. We found that by 2 to the kth power, and 2 to the kth power we found was greater when we used 2 to the 6th power. We had a greater number than the total number of n, which would have been 32. So n is equal to 32, and we have to find a number that's bigger than that when we calculate 2 to the kth power when we use 6, and that number was actually greater than 32. So we have 6 classes. So now we've constructed this, and we want to find out what our frequencies are. Well, we're going to go ahead and come back to our stem and leaf diagram to aid us with that. And for the first class here, from 33 to 47, I'm going to find out how many times those numbers occurred, and that's going to be my frequency. So from 33 to 47, I have 1, 2, looks like 2. I'm sorry, 47. So 33 to 47, I'm looking at 1, 2, 3, 4, because 49 is bigger than 47, so I'll stop there. So I have 4 data points in that class. Now I'll come down to 48 to 62. 48 to 62, so I'll start counting. I've got 49, which will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I have 10 data points in this particular class. So I'll make my tally marks, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'll come down to my third class, which is 63 to 77, and I will start adding those numbers up. So I have 63 to 77, 65 will be my first, so I got 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 data points. So I'll go ahead and plot this with tally marks. 1, 2, 3, 4, 5, 6, 7, 8. Now my next class is 78 to 92. So I'll come to my 7s, and I've got my first one 78. So 1, 2, 3, 4. 4 data points. So I'll make my tally marks. 1, 2, 3, 4. And I'll come down to my next class, which is 93 to 107. I'll come to my stem and leaf and find the first number, which is 95. So I'll start there, 95 to 107, so I'll just count. 1, 2, 3, 4. I have 4 data points. So I'll make 4 tally marks. Now my last class is 108 to 122, and so I'll find numbers greater than 108 and that equal or less than 122. So I have, it looks like 1 and 2, which is 111 and 122. So I have 2. Now what I want to do is I want to add these up so I'm sure that I didn't miss anything, and my total number of tallies will be 32. So I can start counting these real quick, and I'll start counting by 5s here. So I know I've got 5, 10, 15, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Looks like I've made a mistake somewhere, so I'll have to go back and check my work. I've got 5, 10, 15, 20, 24, 27, 28, 29, 30, 31, 32, 33, 34. So I've made a error somewhere, so I'm going to have to go back and check my work. So from 33 to 47, I've got 1, 2, 3, 4. That looks correct. And from 48 to 62, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That looks correct. And from 63 to 77, I've I've got 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8, that looks correct. 78 to 92. 1, 2, 3, 4. 78 to 92, I made a mistake there. So that is 4. Okay, and then 93 to 107. I've got 1, 2, 3, 4, that was correct. And then 108 to 122. I've got 1 and I've got 2. So now I'm going to add these up again and see if I've corrected my mistake. So I've got 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 30, 31, 32. So I've corrected my mistake. So it's always a good idea to make sure that your frequencies add up to your total number that you have with your stem and leaf diagram, and you'll know that you've done your diagram and your frequency table correctly. Now the next thing we need to look at is cumulative frequency. And with cumulative frequency, we're just wanting to have a running total. And basically we're going to start out with 4. And then we're going to add 10 to that, which would be 14. And then, so I don't make any more mistakes, I've got my calculator. So I've got 8, so I'm going to take 14 and add 8 to that. I've got 22. And 22 plus 4 should be 26. And 26 plus 4 should be 30. And 30 plus 2 should be 32. And that should equal your sample size, or your size of data. Should match your stem and leaf diagram, and it should match your frequency column as well. So the next thing I want to do is do what's called relative frequency. And with relative frequency, I'm going to find how relative this class is to the rest of the data. And so I'm going to want to take my frequency here of 4, and I'm going to divide that by the total number of data points, which is 32. So 4 divided by 32 is 12.5%. Now I'll come down to the next class, and I'm going to be looking at the frequency, not the cumulative frequency, and I've got 10. So I'm going to put 10 divided by 32, and that'll give me a value of 31.25%. Now I'm going to come down, and I've got 8. So I'm going to 8 divided by 32 is going to be 0.25, so it's going to be 25%. Now I'm going to come down to 4, and I know I've already calculated 4 is 12.5%, and I've got another 4, so that's 12.5%. And now I've got 2. So 2 divided by 32 is going to give me a value of 6.25%. Now what I want to do here is I want to add these up and make sure that I haven't made a mistake, and you should get a value very, very close to 100, if not 100. So I'm going to take 12.5 plus 31.25 plus 25 plus 12.5 plus 12.5 plus 6.25, and I'm going to sum that up, and I get a total of 100%. So I've done this right. So now the only thing that is empty in this particular distribution table is my midpoint. And it's very easy to find the midpoint because all I have to do is take my lower limit and add my upper limit to that and divide it by 2. So I'm going to take 33 plus 47 and get a total, which is 80 divided by 2. I'm going to get a midpoint of 40. I'm going to do the same thing for each class. So 48 plus 62 is equal to 110 divided by 2 is 55. So that gives me my midpoint. So now I'm going to look at 63 plus 77. 140 divided by 2 is 70. 78 plus 92 is 170 divided by 2 is 85. plus 107 is 200. Divide that by 2, which is 100. Now 108 plus 122 is 230 divided by 2, gives me a value of 115. So now I've finished my distribution table. Now what I'd like to do is show you how to construct a histogram and even a bar chart with this data. So if I have data that looks like this, the first thing I can do is do a very, very easy bar graph. So remember, our frequency is always going to be on our vertical axis, and our data will be reflected on the horizontal axis. And what we can do here with this particular data is we can just do categories and call it class 1, class 2, class 3, class 4, class 5, and class 6. And we'll use our frequencies here. Well, we don't have to go above 10 because that's as high as our frequencies go. So we can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we can do a real easy bar graph with this. So what I'm going to do is I'm just going to use categorical data of classes. And I'll just report on the classes. So class 1 had a frequency of 4. So I'm going to draw my bar all the way up to 4 for class 1. Class 2 had a frequency of 10. So I'm going to go all the way up to 10 with my bar. And then class 3 had a frequency of 8. I'm going to look at 8, plot 8 here. So it looks to be about right here. And hopefully you guys are going to be using graph paper and a straight edge or ruler to get your lines nice and neat when you turn those in for homework. So class 4, it looks like we had a frequency of 4. So it looks like about right here. It looks like class 5, we had a frequency of 4. And then class 6, we had a frequency of 2. So this is what your bar graph will look like. Now if I want to get a little more sophisticated and use midpoints and not have any gaps between these bars, I would use what's called a histogram. And a histogram, it looks similar to a bar chart, but we're going to use our midpoints and we're going to use our lower class boundaries and our upper class boundaries. So what we're going to do here is we're going to report on class 1, but class 1 is going to have a lower class boundary of 32.5, and it's going to have a midpoint of 40. Well, our next class is going to have a lower class boundary of 47.5, midpoint of 55, and an upper class boundary or lower class boundary of the next class of 62.5. So now our data is not going to have any gaps in it. So our first class will have a midpoint of 40. Like I say, we had a frequency of 4. So we're going to look at 4 here. And I've got my lower class boundary, so we're going to go up to 4 and all the way across to our upper class boundary, which is right here. Our next class, which has a midpoint of 55, that occurred 10 times. So we're not going to have any gaps here. So we're just going to go all the way up to 10 and all the way up to our next boundary, which is 62.5. Move that over just a little bit, 62.5. And then our next midpoint is going to be 70. And then we'll just use our upper class boundary of 77.5, and that will be our next class. So that occurred 8 times, so 8 times will be about right here, and we come down. As you can see, we don't have gaps in our data now. So our next midpoint is going to be 85, and our upper class boundary would be 92.5. And we can use that 85 and find out how many times it occurs. It looks like 4 times. So our next midpoint is going to be 100, the upper class boundary of 107.5. And that happened 4 times. And then our next one is 115, the upper class of 122.5. And that would be our next level. And you can see this is not straight or anything. I'm just using a pen, and I'm not very good with a pen. So that's basically how we would do some of these bar graphs and histograms. There's another one I want to show you, and it's called a polygon. It's pretty neat too. So we still have our vertical axis. I'm still going to use 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 for frequency. And this thing is pretty neat because it will give you a profile. For class 1, I have a midpoint of 40. Class 2, I have a midpoint of 55. Class 3, 70. Class 4, 85, Class 5, 100, and Class 6, 115. So now what I want to do is I want to see what this data looks like. So it looks like I have 4. So from 4, I'm going to put a dot here. And then my next class happened 10 times. So I'm going to go all the way up to 10 and make a point there. And then 70 is going to be my next midpoint for class 3, and that occurred 8 times. So I'm going to go up to 8, and then 85 is class 4, and that happened 4 times. Class 5 occurred 4 times, and class 6 occurred 2 times. So now what I'll do, I'll just connect the dots and plot this. So you'll want to use a straight edge or a ruler to do this. But here's how that should look, and that's called a frequency polygon. Okay. So now that hopefully that has answered all your questions on these types of distributions that we're talking about right now. The next thing I want to do is show you how to calculate variance and standard deviation. So I'm going to erase this stuff. I know that's a lot of work to erase, but it has to be done. Well, what I want us to get familiar with, first of all, is the use of sample symbols and population symbols. Well, the first one I want us to get familiar with is X bar. X bar is going to be the average or the mean for a sample. N will be the total observations in a sample. S squared is going to be the variance of a sample. S is going to be the standard deviation of a sample. And this is sample. Population. Well, for our average, we're going to have the Greek symbol mu. And it kind of looks like this. Or an M, or some people think it looks like a U, but it's actually mu. And for our population size, we're going to use an uppercase N. For our variance, we're going to use sigma squared. And then for standard deviation, it is sigma. And this is lower class sigma. Now we will have something called an upper class sigma, and that's going to equal to sum or add. So those are some of the things that I want you to be aware of before we get too far into this. So what I want to do now is I want to show you a formula that we're going to be using. So we're talking about the x bar, which is the average. So we're going to use the sigma. We're going to sum up all of the x's that we have in a data set, and I'm going to show you what that is in just a few minutes. And then we're going to divide all the x's over n. And that will equal our average. So what we want to do is we want to start out with a data set. And our data set may be small, it may be large. Let's just start out with 5, 6, 1, 3, and 2. That's a data set. If you can do these procedures with these small data sets, you can do them with a large data set as well. I'm not going to torture you and make you do data sets of 25 or anything like that. We're going to do small data sets because most of the time we just use computers to compute these things, but I want you to know exactly where the numbers are coming from and how the computer actually computes these values. So we've got a data set. So we have basically, if we start filling in these numbers, and we'll treat this as population data. So we're going to change this to mu, and we're going to change this to uppercase N. So now I'm going to be dealing with this entire population of data. So I have an N that's equal to 5 because I've got 1, 2, 3, 4, 5 data points. Now the next thing I basically want to do is I want to find my mean, my average. And how I do that is I sum up all the x's. And this is an x, this is an x, this is an x, this is an x, this is an x. Some textbooks will have xi or just plain old x. It doesn't matter. I'm not sure, I haven't got the textbook yet for this particular class, so it really doesn't really matter because this is basically the same. My answers will come out exactly the way they will on SPSS, SAS, or an Excel spreadsheet. So we're going to do this correctly. So we're going to want to find the mean. So how we find the mean is we have to sum these up. That's what this formula is telling me to do. So I'll get my calculator and I'll start summing. 5 plus 6 plus 1 plus 3 plus 2 equals 17. Now I want to check that again for mistakes. 5 plus 6 plus 1 plus 3 plus 2, and I got 17, so I've checked my work. You always want to do that. Well, now the next thing says we have to divide it over n, which is 5. So if I take 17 and divide it by 5, I will get my average. So 17 divided by 5 is giving me an average of 3.2. So that is going to be my mean, 3.2. Well, the next thing, that's over here, looks like we've solved all this other stuff. There's a thing called variance. Well, there's another formula for variance. The formula for variance is going to be this sigma again, and we got our mu. I'm sorry, I keep messing this up. We got sigma, which is telling me to add all the x's up. Well, it wants me to subtract mu and square it and divide it by n. So that's what I need to start doing. So I'm going to start right here in the middle. I'm going to take all my x's, which I've got here. I've got 5 x's. And I'm going to subtract mu from each one of them. So when I do that, I know what mu is. It's 3.2. That's my average. So I'm going to come over here and 3.2. 3.2 3.2, and 3.2. Okay, now I have that. Now since I have the average here, I'm going to just go ahead and erase this because I'm going to need that space. So I'm going to start this formula. All right, so 5 minus 3.2 is equal to 1.8. 6 minus 3.2 is equal to 2.8. 1 minus 3.2 is equal to a negative 2.2. 3 minus 3.2 is actually a negative 0.2. And then my last number is 2 minus 3.2 is equal to a negative 1.2. Now I've done this part of it right here. So I want to add these up. It's still telling me to add. Now all the deviation scores, and that's what these are deviating from the mean. If I have the mean, which is right here, 3.2, each score here is actually deviating from the mean. It's either going to deviate in the positive way or the negative way. And we have positive numbers and negative numbers. So we're going to see where these numbers come out. So I want to sum these up so I'll know exactly if I've done this correctly. And if I did, I'll get a 0 right here. So I'll take 1.8 plus 2.8 plus a negative 2.2 plus a negative 0.2 plus a negative 1.2. And when I total that up, I get, well, I probably hit the wrong button. Let me try it again. 1.8 plus 2.8 plus a negative 2.2 plus a negative 0.2 plus a negative 1.2, and that is not coming out right, so I've done something wrong with my calculation, so I'm going to have to go back and check. So I've got 5 minus 3.2, and that is 1.8, that's correct. So I've got 6 minus 3.2, and that is 2.8, that's correct. And I've got 1 minus 3.2, which is a negative 2.2, that's correct. And I've got 3 minus 3.2, and that's a negative 0.2, that's correct. And then I've got 2 minus 3.2 equals negative 1.2. Okay, so I'm doing something wrong because I'm not coming out with 0 here. So 1.8 plus 2.8 plus negative 2.2 plus negative 0.2 plus negative 1.2. And I'm still not getting the right answer. So I'm going to figure out what's wrong.